This is Professor Pelton. This is part one of chapter 5, section 4. So we're doing division with polynomials. So you're either doing a division with a monomial or you're doing division with a polynomial, right? So polynomial basically meaning more than one. So um, your bi, tri, quad, so on and so forth. So the monomials are simple because it's just one thing on the bottom because that's what you're dividing by. So here I'm dividing by 21x squared, y to the first. So I get 14 over 21 um, which doesn't divide, but it does simplify to 2/3, right? We're going to use the quotient rule of exponents. Whoops, that line didn't work out very well, which is subtraction of exponents. So we have x to the 8 minus 2, and then 3 minus 1, because the exponent rule is subtract for exponents, right? So that's x to the 6th, y to the 2nd. Okay. All right, and if you have more than a monomial on the top, that's fine. Just divide every term by the monomial on the bottom. So 5x squared over 30x plus 3x over 30x and minus 2 over 30x. So essentially I get, let's see, 1/6 x to the 1, right? Plus 1/10 x to the 0, right? Because 1 minus 1 is 0. And then let's see, minus 1/15 x to the negative 1, right? Because what I really have here is x to the 0 over x to the 1, right? Which is x to the 0 minus 1, which is x to the negative 1, right? Because you really have x to the 0 there. So what I really get is x over 6 plus x, no, there's no x there, I'm sorry, it's just 1/10. 1/10 minus 1 over 15x will be our final answer. Okay, pause the video, try the student problem for yourself. Okay, so first is a monomial over a monomial. So I'm going to get 2/3 with a common factor of 5, x9 minus 3, and then 4 minus 6. So I get 2/3 x to the 6th, and then y to the negative 2. So I get 2x to the 6th over 3y squared. That's our final monomial answer. Okay, so the next one, divide every term by the 2x y squared, so 4y over 2xy squared minus 6x to the fourth y to the third over 2xy squared minus 3x to the fifth y2 over 2xy squared, and then finally plus 5x over 2xy squared. Okay. All right, so 4 over 2 is 2. So we get y to the 1 minus 2 and x to the 0 minus 1, right? Because we have 1 there, 1 there. And there's an x to the 0 essentially on the top up here, correct? So minus 3, 6 over 2. So we get 4 minus 1, and then 3 minus 2, minus 3 over 2, x to the 5 minus 1, and then y2 minus 2 is going to be 0, so I'm going to leave that off, plus 5 over 2, x to the 1 minus 1, and then y to the 0 minus 2. Okay, so looks like we're good there, so we can just simplify everything now. So it looks like what we're going to get is, I didn't leave myself enough room here very well, did I? 2 over xy minus 3x to the third y minus 3 over 2x to the fourth plus 5 over 2y squared. Okay, there's our answer there. I didn't space that very well, but that's okay. All right, because remember, if you get a negative exponent, then it has to go to the bottom. All right, so what if I have to divide by, right, something that's not a monomial? Then you have to do long division, essentially, just like you did in grade school when it's several digits, right? So we'll do a comparative example from grade school. right? So let's say I'm going to divide something into, I don't know, how about 12 into, I don't know, 3,854 sounds good, just making up a number. So 12 goes into 38 three times. So that's 36. So I subtract that, I'm left with 2, right? All right, so let's do equivalent over here. So 3x minus 2 is dividing into the polynomial, which is 6x to the third, minus 1x squared minus 5x plus 4. Notice that that is in descending order and not the order that's given in the original problem, because the number 3,854, that order matters too, right? I can't just rearrange the numbers, okay? So the order matters. So same thing, 3x times what gives me 6x to the third power? Well, that'd be 2x squared, right? Because essentially the 3x times whatever's being on the top will give me the number that's on the bottom, which is going to give us 6x to the third, right? But just like here, it was 3 times the 1. I have to do 3 times the 2 also, don't I? Which is why I get 36. So same thing. This term times the 3x and this term times the negative 2 gives me negative 4x squared. So the only thing that's difference between grade school division and in this algebraic division is I have to put parentheses around it because you subtract the whole thing. Similarly over here, you can put parentheses around this. It won't make any difference over there because you don't add the 8 and the 6, you subtract them. But it does make a difference here because it's two terms. So this gives me 0x to the third and then 3x squared. Then I'm going to bring down the next term. Right? So similarly here, I'll bring down the next term. So 12 times 2 gives me 24, which is the closest one accordingly. So if I go over to here, this will be plus 3x to the first. So that times 3x, right, gives me 3x squared. And this times the 2, or the negative 2, gives me minus 6x. Okay. Um, oh, I don't need the 3 actually. I'm sorry. I don't need the 3 because 3 times 3 would give me 9. So this is actually wrong. So I actually only need a 1 because 1x times 3x gives me 3x squared. And then 1x times negative 2 gives me negative 2x. Okay, so that'll actually cancel. So when I subtract, I get negative 3x, and I bring down the 4. There's my next term. So over here, I'm going to bring down the 4. So 12 times 1, it leaves me with 2 left over. So I go over to here, I'm going to multiply by negative 1. Okay, so negative 1 times 3x is negative 3x. Negative 1 times negative 2 is positive 2. So if I subtract, I'm left with a 2. And there's nothing else for me to bring down. So my answer is 2x squared plus 1x minus 1 plus a 2 left over, which is 2 of 3x minus 2, because that's what I was dividing by originally, right? That was the original thing I was dividing by. So over here, it'd be 2 over 12 in grade school example, right? Okay. All right, pause the video and try the student problem for yourself. Okay, so we need to put these in proper order. So x minus 3 is in the proper order. And over here, we get 6x to the third minus 1x squared minus 5x plus 4. Okay. Okay, so x times what gives me 6x to the third? So if I multiply it by 6, I only get 6x, right? So I need some more x's. So I need 2 more x's. That'll give me x to the third. So then I times it by this. I get minus 18x squared. Then I'll subtract. So that gives me 17x squared. Then I'm going to bring down the next term and get minus 5x. Okay, so x times what gives me 17x squared? So plus 17x. So if I multiply that, I get 17x squared. Multiply that by the negative 3. Let's see, that's going to be what, 51, I want to say? And I'll subtract that. That's going to leave me with 46. Bring down the next term, which is a 4. So if I want to multiply that, it'd be what? 46, right? So 46 times the x gives me 46x. And then 46 times the 3 gives me, ooh, it's a big number, isn't it? So 3 times 46, that's 118, 12, 13, 138. So that's what, negative 138? I think we're good there, right? Yep, I think we're good. Okay, so that means that's going to be what? A positive when I add that together. So that's 142. Okay, so my actual answer is 6x squared plus 17x plus 46. And a remainder, what did I say, 142? So 142 over the original divisor. So this is equivalent to this essentially. Okay, so let's go to the next page and talk about place value. So let's think about this problem here. So I must account for the 0 term. So if x sub a exists, then x sub a plus 2 must also exist, so on and so forth. Okay, so what does that actually mean? So if we think of a simple grade school example, 2 divided by 14, or 14, I'm sorry, 14 divided by 2 is not the same as 104, correct? So that 0 is a very important place value to the problem, correct? So let's take this equivalent algebra one. So x plus 2 is being divided into the polynomial, which is 5x to the third plus 0x squared plus 6x to the first plus 8. Okay, so that's 0x to the second power just gives me a 0. So that's acting as a placeholder value because I need everything to line up. So it goes 3, 2, 1, 0 as far as the x terms go. Okay, so if I multiply this by 5, I'm just going to get 5x. So I need really an x squared there. So it'll give me x to the third. Then I multiply this times the 2. So I get 10x squared. And now what you notice is they actually line up properly. So when I subtract, I get negative 10x squared. We'll bring the 6x down. Okay, so the next term would be minus 10x to the first times the x gives me minus 10x squared times the 2 gives me minus 20x. So when I subtract, I'm going to get 26x. And I'll bring down the 8, right? We're bringing down the 8. So my next term is plus 26 times the x gives me 26x. 26 times the 2, they give me what? 52, correct? Yes. So if I subtract, I get what? Negative 44. So what I really get is 5x squared minus 10x plus 26. What did I say? Minus 44. So plus negative 44 over x plus 2. You can either put it as minus 44 over x plus 2 or plus negative 44 over x plus 2. Either way, this is equivalent to that when you simplify. All right, pause the video and try a student problem for yourself. Okay, so again, make sure they're in the proper order and no missing terms is the first precedent. So x plus 2 is dividing into x to the third power plus 0x squared minus 7x to the first minus 6, and it's really x to the 0 power. We don't need to put that though. So x squared times x gives me x to the third, and then x squared times 2 gives me plus 2x squared. Put parentheses around it and subtract. So I get negative 2x squared minus 7x. Okay, so the next term is going to be minus 2x to the first, because if I times that by x, I get minus 2x squared. Negative 2x times 2 is negative 4x. So if I subtract, okay, I'm going to get what? Negative 3x. And I stress putting these parentheses because if you don't, I see a lot of mistakes by students who refuse to put the parentheses out of stubbornness because you need to subtract both terms, not just the first one. Okay, so this is the only departure from high school really, or grade school. Okay, so next term must be minus 3, because negative 3 times x is negative 3x. And negative 3 times 2 gives me minus 6. So if I subtract, I'm actually left with nothing. So this one actually divides in perfectly. So x squared minus 2x minus 3 is actually what this equals. Okay, which is fine. Lots of things going perfectly, right? 4 goes into 12, doesn't it? The answer is 3, so there's no remainder. Okay, that is the end of part 1.